7 planets have just been discovered. I am quoting from NASA.gov here. A bumper crop of Earth-size planets huddled around an ultra-cool, red dwarf star could be little more than chunks of rock blasted by radiation, or cloud-covered worlds as broiling hot as Venus. Or they could harbor exotic life forms, thriving under skies of ruddy twilight. Scientists are pondering the possibilities after this week's announcement. The discovery of 7 worlds orbiting a small, cool star some 40 light-years away, all of them in the ballpark of our home planet in terms of their heft, mass, and size, diameter. 3 of the planets reside in the habitable zone around their star. TRAPPIST-1, where calculations suggest that conditions might be right for liquid water to exist on their surfaces, though follow-up observations are needed to be sure. All 7 are early ambassadors of a new generation of planet-hunting targets. Red dwarf stars, also called M-dwarfs, outnumber others, including yellow stars like our Sun, by a factor of 3 to 1, comprising nearly 75% of the stars in our galaxy. They also last far longer, and their planets are proportionally larger compared to the small stars they orbit. That means small, rocky worlds orbiting the nearest red dwarfs will be primary targets for new, powerful telescopes coming online in the years ahead, both in space and on the ground. The majority of stars are M-dwarfs, which are faint and small and not very luminous, said Martin Still, program scientist at NASA headquarters in Washington. So the majority of places where you would look for planets are around these cool, small stars. We are interested in the nearest stars, and the nearest stars are mostly M-dwarfs. But these are sure to be perplexing planets, with strange properties that must be teased out by careful observation as well as computer simulations. Finding out whether they can support some form of life, and what kind, likely will keep astrobiologists working overtime, perhaps attempting to recreate in the laboratory some of the conditions on these red-tinged worlds. We're definitely all working overtime now, said Nancy Kiang, an astrobiologist at NASA's Goddard Institute for Space Studies in New York City. Would life find a way? Expert opinion on whether red dwarf planets are suitable for life tends to tick back and forth like a pendulum, said Sean Domingal Goldman, a research space scientist at NASA's Goddard Space Flight Center in Greenbelt, Maryland. We've come up with these theoretical reasons why such a planet might struggle to be habitable, he said. Then we look at those theoretical concerns with a little bit more detail, and find out it's not that big of a concern. Then some other theoretical concern crops up. At the moment, the pendulum is ticking back toward lifelessness. Recent findings suggest life would have an uphill battle on a planet close to a red dwarf. Largely because such stars are extremely active in their early years, shooting off potentially lethal flares and bursts of radiation. These youthful tantrums would go on for quite some time. Red dwarfs smolder at much lower energy than our Sun, but live much longer, perhaps with lifespans in the trillions of years longer than the present age of the universe. Our Sun is expected to burn out after shining for something on the order of 10 billion years. We're about halfway through its lifespan. The exact age of the TRAPPIST-1 star is unknown, but scientists believe it is at least 500 million years old, or about 1/10 the age of our 4.5-billion-year-old Sun. Some are born to endless night. Red dwarfs could take their first billion years just to calm down enough to allow any nearby planets to be habitable. And the habitable zone around such stars is very close indeed. All 7 of the Earth-size planets crowd so close to their star that they complete a single orbit their year in a matter of days. 1.5 days for the nearest planet and 20 days for the farthest. That kind of proximity means the planets are probably tidally locked, with one face always turned to the star, the same way our moon presents only one face to Earth. And while red dwarfs are cool compared to our Sun, they would loom large in the sky of a close, tidally locked planet, perhaps baking the sunward face. The far side, meanwhile, could be trapped in an eternal, frozen night. The right kind of atmosphere could mitigate such effects, transporting heat to the planet's far side and helping to moderate the climate overall. A recent study that relied on computer simulations of red dwarf planets, however, delivered more grim news. The flaring tempers of young red dwarfs, with their bursts of high-energy X-rays and ultraviolet emissions, could actually strip oxygen from the atmospheres of nearby planets, according to the study by a team at NASA Goddard led by Vladimir Arapetian. Other scenarios involve stripping away the atmosphere altogether. Yet another potentially sterilizing effect. Even for M-dwarf planets that manage to hold on to their atmospheres, would result from high-energy radiation triggering a runaway greenhouse effect, Donegal Goldman said. Maybe you would end up in a stable climate that's too hot to support life, he said. But so little is known about how life gets its start, and how common or rare it might be in the cosmos, that tenacious life on M-dwarf planets remains a distinct possibility. Although loss of atmosphere. End of quote. This is a fascinating discovery that I thought I should share.